Good morning, I am Mr. Is. You are joining me for this video on shaded areas. I plan to make this a very beneficial video for all of you because this type of question is a favorite among standardized tests. And the best way to look at this is just directly get into these two questions we will be looking at. Find the area of the shaded portion, and this shaded portion you're seeing is right there before you. You have a circle within which is inscribed a square. How can we go about determining that? Think about it. If we were to determine the circle area and minus from that the area of the square, we would get four difference regions. We would get this, and that. But since we're only focusing on one, that resulting cumulative difference, if you were to divide that by 4, it would give you that specific area right there. Because each of these, this figure is not drawn to scale, but each of these would be equal to each other because you have a square within a circle. If you are starting out here with a square, it has a diagonal of 4 and you have two sides which are x, and these sides are always equal. You can use the Pythagorean ratio. X squared plus x squared is equal to 4 squared. Think about it. X squared plus x squared is equal to 4 squared, which is your diagonal. A squared plus b squared is equal to c squared. 2x squared is equal to 16. X squared is equal to 8 and x is equal to 2 root 2. That represents the side of the square, and that'll come in handy in the determination of the square area. Now let's talk about the circle. This diagonal here very well mimics and represents the diameter of the circle. If the diameter here is equal to 4, then the radius must equal to 2, half of that. And we can easily determine the area of the circle now. Area of a circle is equal to pi r squared, which in this instance will be 4 pi. From that, if you were to minus the area of the square, and we know the sides are 2 root 2, right? Minus 2 root 2 square, which is length times width, you'll get 4 pi minus 8. 4 pi minus 8 now represents the difference of the circle and the area of the square. The circle area and the square area in all of these four regions is equal to 4 pi minus 8. Now if you were to divide this by 4, it'll give you just that area on the top, and you can say your answer is pi minus 2, and your answer would be good, because here I've just done 4 pi over 4 minus 8 over 4, and that gives you my pi minus 2, and here's the area of this specific portion, and the answer is good, and we are done with this question. This here serves as a good second question for this video. It's an excellent example of the type of question you want to be prepared for. We have to find the area of this shaded portion. You were starting out originally with a circle which was cut in half, and it gave you this semicircle that you see. Within this semicircle, we're seeing a bunch of lines. We have this outer line AB, a segment AB which has a length of 10 units. This AB segment has been bisected by this line CD. CD bisects AB, and you know when you bisect something, you're bisecting it into two equal halves. If all of this represents a dimension of 10 units and CD has bisected it, we're looking at 5 and a 5. And this very well represents a good diameter for a semicircle, or a diameter which would have been potentially for a whole circle. And this here would very well represent the center of that circle through which CD is going through. Any line drawn from the center to the outer edge of a circle is always a radius, and all of these phi's represent potential radii. We know a bisecting line would very well create a 90 degrees in this specific representation. How can we go about determining this shaded area? If technically you were to calculate the area of the circle and you were to divide it by 2, you'd get the area of the semicircle. We would get the area of a semicircle and half a circle. If you were to divide this again by 2, then we would be getting the area of that half semicircle which we are interested in. Within this semicircle, we have a triangle drawn. If we have this area of this half of a semicircle and we minus from that the area of this triangle, we'll get that area of that shaded portion that we are interested in. So the best thing we can do right now is determine the area of the circle, and we can proceed from there. If the radius of this circle is a 5, then the area of the circle must be 25 pi, because you're doing pi r square. 5 times pi, 25 pi. If you make this half, if you do this divided by 2, you're getting, well, let's just keep everything in fractions. 25 pi over 2, that's the area of this semicircle. But we need to half it out again, because I only want to focus on this part right here, all of this. If I divide this, or I multiply by 1 or 2, I'm getting 25 pi over 4, which represents this portion only. If I can somehow minus the Area of the triangle, I'll get that area of that shaded portion. What's the area of the triangle? You know that triangles always have base times height, and I have a base and I have a height. Times 5 times 5, and I'm getting 25 over 2. So what must be the area of the shaded portion? Let's come right over here. Area of the shaded region, SR. Area of the shaded region is equal to 25 pi over 4 minus 25 over 2. We can do a good answer here. We have a common denominator of 4. It'll be 25 pi minus 50 over 4 units squared. We can put units squared, and that right there is my answer. We'll just, for clarity reasons, bring it right here. 25 pi minus 50 all over 4. It represents the area of this shaded portion, and it should be good. And with that, we end this video. Thank you for watching. Stay tuned. Have a nice day.